Hi everyone, welcome to this new video. My name is Aditya, and on this channel I talk about Kubernetes, blockchain, and software in general. And in today's video, I'm going to show you how you can integrate HSM with custom security authority in a Hyperledger Fabric network. So let's see how we are going to do all of this and what we are exactly going to do. So I'll show you three scenarios that I have discussed previously as well. And the scenario number third is the scenario that we are going to implement in today's video. So this video is going to be slightly advanced video and I'll not go much deep into the implementation. Rather, I'll talk about the foundational steps that what we are going to do and how we are going to do. And then I'll walk you through the code as well. Okay, so if we go to the screen here, this is a very basic implementation of a Fabric n- network where you have a Fabric network, and then we issue the certificates for a given user with the help of Fabric CA. So typically what we do, we implement a library called Fabric CA client, and this library is available in Node.js, Java, and I think Golang as well. And using this particular library, you can issue certificates for your users, and then users can do the transactions with the help of these certificates and the private keys that are issued to them, right? So this I have discussed in almost most of my Fabric related videos. So typically what we do, we register a user, we send a registration request to the Fabric CA, and then Fabric CA registers that users into the Fabric CA database. And then next step is to do the enrollment. Now, once we do the enrollment, we get the certificate and the private key back, and then we store these keys into a wallet. And from there, user can do the transaction with the help of those public and private keys. So this is a very vanilla implementation. Where we are using Fabric CA, and we are using Fabric CA client. This is a live client library which helps us in interacting with the Fabric CA. Very simple flow. We have discussed this in multiple videos. Uh, Now, the other scenario that I want to talk about is the slightly advanced scenario. This is not the core agenda of this particular video. Rather, this is one of the implementation that I have shown in one of our previous video, where we were integrating Fabric CA with the SoftHSM. So typically what happens in this particular scenario is that user sends a request to the Fabric CA client. Again, this client is using Fabric CA client SDK. And we also have one more component called HSM. HSM is basically a hardware security module component. Typically, they are hardware devices where you can store the cryptographic tokens, private keys. You can store all of these in the HSM. And if you want to sign some data, then you can use that in the HSM. Like HSM can directly sign the data for you because HSM has those keys that you have stored. Now, when we want to integrate Fabric CA with the soft HSM, this is how it is going to look like. So your soft HSM is running here. Again, soft HSM is a software-based implementation of HSM. We typically don't use soft HSM in the production, but for testing and development purpose, you can use soft HSM. So in order for Fabric CA client application to interact with the software system, we need a library called PKCS11 library. Again, whenever you are going to install software system, you will get this library out of the box available on your machine. Now, what happens is whenever user makes a request, that request goes to the Fabric CA client application. This application can be written in Node.js, Java, or Golang. Now, we send that request, a registration request to the Fabric CA so that the user can be registered onto the system. And once the registration happens, then the client application again sends a enrollment request. And we already know that the enrollment request is to get the certificates back from the Fabric CA. Now, once we get these certificates and the private keys back, these are stored into the soft HSM. So again, we are using a library called PKCS11 library that helps us in interacting with the soft HSM. So these certificates and key, especially the private key, stored into the soft HSM. And whenever we have to do a transaction, we typically ask HSM to sign that payload and give us back to the client application. So if you see here, we get the certificate and the private key back. And then the certificates are stored into the wallet. So you can use any wallet here, like file system wallet or CouchDB or maybe an in-memory wallet. Any wallet is fine. But the crux here is that we store the certificates here, because private key is already stored into the SoftHSM. Now, whenever we want to do a transaction to the Fabric network, what we do, we typically integrate the Fabric CA client library with the SoftHSM, and whenever we have to sign a transaction, the request is sent to the SoftHSM, where the transaction signing part happens along with the help of wallet. Remember this thing, and the signed transaction is then sent to the Fabric's network itself. So this is how this particular scenario looks like, where the keys are stored into the SoftHSM. Again, the users are registered into the Fabric CA. And once we do the registration, we get the certificate and the private key back. Private key stored into the SoftHSM, and the certificate is kept into the wallet. Now, whenever we have to do a transaction, again the signing request for the transaction is sent to the SoftHSM, where the signing happens. And once we get the signed response from the SoftHSM back, we send that signed response to the Fabric network. This particular scenario has been discussed in a previous video. I will recommend you to check that out if you want to gain more insights how this is actually implemented. I'm not going to go to the implementation in this particular video for this scenario. Now, the third scenario, this is a slightly advanced scenario where now we have removed the Fabric CA, and rather we are using a custom certificate authority. And in this particular case, I'm using a certificate authority called EJBCA. It's a certificate authority. And now, again, this certificate authority is integrated with SoftHSM. So the goal here is that we want to store the private keys in the SoftHSM, and the public keys or the certificate can still reside into the wallet. So let's talk about how this is actually implemented in EJBCA. Along with SoftHSM. So whenever we want to register a user onto the system, again, this is my implementation, your implementation may vary. So here I'm using two services. One is a Node.js application, it's a client application. And second one is a Golang application, which is actually interacting with the EJBCA to get the certificates, and then SoftHSM to store those private keys and sign the data. So this client application is a Node.js application. So whenever we want to register a user, the request is sent to this client application. And this client application now that sends that request to my Golang application. Again, there is a endpoint that I have created in this Golang application, over which we can send the data, like what should be the username that we want to register. And uh, once once the request is received by the Golang servers, this application, the request is sent to SoftHSM in order to create the keys. So again, if you see here, the keys are generated within the HSM. Like the keys are never exposed in your Golang application, rather the keys are directly generated within the SoftHSM. So what we are doing here is we are generating a private and a public key, and then once we have these keys available into the HSM, we are creating a CSR, which is a certificate signing request. The CSR is signed by the SoftHSM itself. Like this, the signing is happening within the SoftHSM, and we have the signed CSR. And then the CSR is sent to EJBCA, so that EJBCA can sign my that CSR and can give me the certificate back. So the request is sent to the EJBCA, where I get the signed, where I'm sending up the TSR, and then finally I'm getting the certificate back. Now remember here that the keys are stored into the SoftHSM, right? They are never sent anywhere, either in the EJBCA or to the Golang applications. They are still generated in the HSM and stored in the HSM rather, and we are sending the CSR to the EJBCA and getting the signed certificate back. Now, if you see here, the certificate that we got back, we are giving back that certificate to the client application Node.js, and then this is stored into the wallet. So again, I can just draw it quickly here, the wallet part. So this is my wallet, where I'm storing only the cert, because private key is anyway stored into the SoftHSM. And this can be file system wallet, or any kind of wallet that you want to implement, maybe file system or CouchDB or in-memory wallet. And This is stored here. Now, whenever we want to send a transaction to the Fabric network, what we do typically, this client application is also connected to SoftHSM, again using the same PKey CS11 library, and the certificates are already stored into the wallet. So what we do, since the keys are stored into the wallet, we have to sign the transaction. And here we use a Fabric CA client library because that can easily interact with the SoftHSM or any HSM along with the wallet. So my certificates are present here. My keys are present in the SoftHSM. We use that Fabric CA client library and do the transaction signing part. And once the transaction is signed, this transaction is sent to the Fabric network. Let me quickly show you the implementation that I have done. So this is my implementation. So the Golang application that I was talking about, this is the Golang application. This is connected to SoftHSM, and SoftHSM is running locally on my machine. So here you can, I will show you the endpoint that I was talking about. So here you can see that this is the endpoint, which is the enroll endpoint, and we receive the request. There's a post call, and here this is the body that I am expecting here. And if you see here, I am creating a new HSM session, and here I'm passing that library path. And then you can see here that I am simply calling this function enroll certificate handler. Now, if we go to this particular function, here we are generating up a key pair, the private and the public key. If we go to this particular function, here you can see that I am calling this generate key pair on the HSM module. And this is the attributes of my public key and the attributes for the private key. Now, if you see here, since Fabric only accepts elliptical curve key pair, so here you can see in my public and the private key, I'm using the properties as elliptical curve. Here in the private key as well, you can see this. And then I'm calling this generate key pair, where I'm passing the key pair generation mechanism, which is elliptical key curve here. And then I'm passing the public and the private key pair attributes. Now, once I do this, I get the public and the private key back. Again, these are not the actual keys. These are the uh, objects that are stored into the HSM. These are not the direct keys. And to post that, once I have this particular key pair, then once we get the signer object back from this particular function, then I'm creating the CSR. And if you see here, this is the certificate signing request that I'm creating. And you can see that I'm passing the common name, organization, country, all these parameters is what I'm passing. Then I'm creating a CSR here, and this is the CSR. And once I have the CSR, then I'm sending up this CSR to the EJBCA so that EJBCA can give me a certificate back that is generated with the help of that CSR. So here you can see we got the CSR back. And then I'm calling this function called enroll certificate. I'm passing my CSR here. And if you see here, I'm making a call to the EJBCA. So here you can see that I'm making a post call to the EJBCA endpoint. And then EJBCA is going to return me the certificate back. So here you can see that in the response, I'm getting the certificate back, and I'm simply decoding that certificate. Because the response that we get, it's in a base64 encoded format. So once we have the certificate back, we return that certificate back to the user. So let me go back to the function. So here you can see that we are returning the certificate back to the user. Now I'll show you the Node.js application as well. So here you can see that this is the library path, my PKCS11 library path. This is my SoftHSM pin, and this is the label where I am storing up all my tokens. Now this is the function. The function that is going to run is main function. If you see here, I'm creating a wallet first. It's a wallet that will get created here. Then I'm just setting up a provider as SoftHSM. So here you can see that I'm setting up the provider configuration. If I go here, these are the provide HSM configuration. And then I'm simply enrolling that user. So I'm checking whether that particular credential is present in the wallet or not. If that is not present, then I'm simply enrolling it. And in this enrolled request, what I'm doing, I'm sending up that request uh, to my Golang application, and I'm sending passing all these parameters that is needed as the part of this particular request. Now, once I get the certificate back from this particular function which is enrolled, I'm setting that storing that certificate into the wallet. Here you can see that I'm doing a put wallet function, and post it like I'm simply sending up a transaction to the Fabric network. So here you can see I'm calling this function called create asset, and these are the parameters that I am passing. Uh, Let me try to see if I can execute this particular request. And this is the configuration file. So here you can see that this is the PKCS11 library path, and this is the same pin that I am using, because I am using single instance of the SoftHSM at both places, at the Golang and the Node.js service. So let me quickly run this. Okay, so my Golang application is running, and now I'll create one more terminal here, and here I'll run my Node.js application. So if you see the Node.js application, what we are doing here is in the main function, I am trying to see if that user, so I'm going to register a user called app user one, and then the transaction will be signed by this particular user. So let me run this node temple. Let's try to run this. Okay, I need to do a npm install first. So first I'm installing up all the dependencies because I don't have them here. Okay, package.json is also missing. And I want to install few of these libraries. Axios. I think, yeah, these two libraries are required. So here you can see that we are not using any Fabric CA client library. So the HSM provider is already given to us from the Fabric network library, and we are using the same. So there is no involvement of the Fabric CA components because we are not using it. In place of Fabric CA, we are using a third-party certificate authority called EJBCA, and for to get the certificates. Now let me run this. Okay, let me set up the SoftHSM configuration first, and let's try to run the application now. And let me also initialize the SoftHSM. So I'm initializing a SoftHSM with label called my token 2, and this is the pin that I'm using. Okay, first I need to generate this folder, because this is the configuration that I have given in my SoftHSM configuration file. This is the particular location. Now let me create this directory. I'll have to run with sudo. Okay, so the folder is created, and now let's try to initialize it. So slot 2 does not exist. Let's scale any slot 1 maybe, or let's give the slot 0. So this slot as well does not exist. Let omit the slot flag. We'll use hyphen free, so it's going to give us a slot. So slot 0 has free or uninitialized token. Okay. So let's see the available slots. So okay, let me export the SoftHSM configuration. Okay, so here we can see that there is slot 0, and let's try to initialize. Okay, so let's do a thing. So I'll give the current directory path here. So instead of this, I'll use this particular path and slash token. So I have a folder called token here, and let's see the slots available. SoftHSM to util, show slots. So slot 0 is there. Let's initialize a slot. So this slot has been so slot 0 is free and a token, and we've got this slot number. So if I do show slots again, here we can see that the slot 1 is allocated to us, and not the slot 1, basically this particular slot is allocated to us, and here we can see the label as well, which is my token. This is the same label that we gave here. Okay, now we have the SoftHSM configured, and now let's simply run the Node.js application. So my Golang application is already running. Let's run the application, Node.js application, which is sample Node.js -app.js. Okay, it cannot find this connection.json. Let me quickly bring that file here. Okay, so I have brought all the configuration that is needed, like the connection.json, it's a connection profile, and the admin certificate and the key. This is the certificate and the key for the EJBCA. In order to access EJBCA, we need this. Let's run this now. Okay, this particular application is not running. Let's run it now. Let's run this Golang application again. And once this is running, then we can simply execute the Node.js script that is going to register a user and then do the transaction. This is empty. Let me delete the wallet. Okay, so this is running. Now let's run the Node.js application. Okay, so here you can see that we got the certificate back. And if you see, the request was received by this particular endpoint, which is enrolled. And we have got the certificate back from the EJBCA. And then we can see the transaction is committed successfully, which means that we are able to accomplish what we wanted to do here. So let me go to the diagram. So what we want to do here is that this client application is going to send the request to the Node.js application, which is going to generate the public and the private key in the HSM. And in order to get the certificate, we used to sign that CSR. We used to get a CSR, sign it with the HSM, keys in the HSM, and then it used to go to the EJBCA, where we get the certificate back. And the certificate sent back to the Node.js client application. and it is stored into the wallet. So certificate is stored in the wallet and the key is available in the SoftHSM. Then we are doing a transaction with the help of Fabric Network library. So here you can see that this is what we were trying to do here, right? So this was it for this video. I know this was a slightly advanced tutorial. I know you guys might be having some doubts. So feel free to reach out to me. Either you can reach out to me via the comments, or you can just reach out to me over LinkedIn, Twitter. And if you are interested in learning about how to build enterprise hybrid fabric network, then feel free to check out my course. And you can find the course link in the comment. And yeah, that's all. So this was it for this video, and I'll see you in the next one.